Okay, now for the dimensional analysis in fluid machinery. Introduction. Fluid flow is influenced by several parameters like geometry, fluid properties, and fluid velocity. In the study of flow of real fluid, analytical methods alone are found insufficient. Real fluids. Experimental methods and results have contributed heavily for the development of fluid mechanics. The solution of realistic problems usually involves both analytical and experimental studies. Experiments are used to validate analytical results as well as generalize and extend their application. Depending either solely on analytical methods or experiment for the design of system is bound to lead to inadequate performance and high cost. Experimental work is rather costly and time-consuming, particularly when more than 3 parameters are involved. Isa-isahin mo yun, one by one. Hence, it is necessary to plan the experiment so that most information is obtained from fewest experiment. This is now the purpose of dimensional analysis. Okay? Dimensional analysis is found to be a very useful tool in achieving this objective. So the mathematical method of dimensional analysis comes to our help in the situations. The number of parameters can be reduced generally to 3 by grouping relevant variables to form dimensionless parameter. In addition, these groups facilitate the presentation of the result of the experiment effectively and also to generalize the result so that this can be applied to similar situations. Flow through pipes can be considered as an example. Viscosity, density, flow velocity, and diameters are found to influence the flow. If the effect of each of these parameters on flow is separately studied, the number of experiments will be large. Also, these results cannot be generalized and its usefulness will be limited. When the numbers of these variables are combined to form a dimensionless group like U, D, mu, rho over mu, few experiment will be sufficient to obtain useful information. Okay? So symbols already, alam nyo na. These parameters can be varied by varying one of the variables which will be the easier one to vary. For example, velocity U. The result will be applicable for various combination of this parameter and so the results can be generalized and extended to new situations. The results will be applicable also for different fluid and different diameters provided the value of the group remains the same. The use of the result of dimensional analysis is the basis for similitude and modal analysis. Okay? And, dimensional analysis is yung mga elimination ng units, consistent units. Yung comparison naman is dito na tayo sa similitude and modal analysis. Similars. So example 1. So ito yung example 1. Hindi ko example 1. Ganito rin gagawin nyo sa solution na gagawin nyo. Okay? Example 1 is present lang yung difficulties ng maraming experiment. Okay? The drag force F on a stationary sphere in flow is found to depend on diameter D, velocity U, velocity rho, and density mu. Assuming that to study the influence of a parameter, 10 experimental points are necessary. Estimate the total experimental points needed to obtain complete information. So indicate how the numbers of experiment can be reduced. Given the drag force F, diameter D, velocity U, and fluid density rho, and then viscosity mu. Required the total experimental points and number of reduced experiment. Solution. To obtain a curve F versus mu for fixed values of rho, mu, and D, experiment needed is 10. Okay. So 1, 2, 3, 4, 5. To study the effect of rho, this experiment should be repeated 10 times with 10 values of rho, the total now being 10 squared. The 10 squared experiment have to be repeated 10 times each for different values of mu. So total experiment for u, rho, and mu is 10.3. To study the effect of variation of diameter, all the experiments have to be repeated 10 times each. Hence, total experiment required 10 exponent 4. That is 10,000 actual experiment. Experiment kasi actual, di ba? Di man yung dodoktoran mo lang. This experiment, meron kang mga instrument, 10,000 times mong uulitin yon. Okay? Yan ang sagot. So, this parameter can be combined to obtain two-dimensionless parameter, which is f over rho u squared d squared is equal to f times rho u d over mu. Yan yung Reynolds number. So now only 10 experiments are needed to obtain a comprehensive information about the effect of these 5 parameters. Yan, 10 lang. Experiment can be conducted for obtaining this information by varying the parameter u, d, rho over mu, and determining the values for f over rho u squared d squared. Note, it will be almost impossible to find fluids with 10 different densities and 10 different viscosities. Di ba? Yan. Kaya hindi pwede yun. Kaya meron tayong dimensional analysis. Okay? Methods of determination of dimensionless group. Merong intuitive method. First, intuitive. Meron pang Buckingham method. Okay, later na yan. So, merong intuitive method. This method relies on basic understanding of phenomenon and then identifying competing quantities like type of process or length, etc. and obtaining ratio of similar quantities. So, mga relationship ng force, density, yan. Ano yung relationship niya? A functional power relation is assumed between the parameters and then the values of indices are solved for to obtain the grouping indices. Yan yung mga A, B, C, D na nakikita nyo. For example, in the problem in example 1, can write pi 1, pi 2 is equal to f exponent A, rho exponent A, B exponent C, D exponent C, mu exponent D, E exponent U exponent E. So solve for A, B, C, D, U. Okay? Na, hindi natanggal na naman. Okay? Wait, ayusin natin to. Okay, ito na lang. Some examples are viscous force versus inertia forces, viscous force versus gravity force, or roughness dimension versus diameter. This is a difficult exercise and considerable experience is required in this case. So, then, yan. Kasi yung animation, di natanggal. Doon kasi uso yung animation, ngayon di na usong, di ko masyadong yung animation kasi nakaka-istorbo siya. Noon, nakakatuwa. Pero ngayon, nakaka-istorbo sa iba. Di ba? Okay. So, kailangan dito ng experience at mga mastery. Magkapamilyar ka na sa intuitive method. Next method is the Rayleigh method. The values A, B, C, D, E are obtained by comparing the dimension on both sides and the dimension on the left-hand side being 0 as pi terms are dimensionless. So, may exponent mo, i-equate mo siya doon as 0. This is also tedious and considerable expertise needed to form this group as the number of unknowns will be more than the number of available equations. This method is also called indicial method. Next type is the Buckingham pi theorem method. The application of this theorem provides a fairly easy method to identify dimensionless parameters, numbers. However, identification of the influencing parameter is the job of an expert rather than a novice. So, ito yung gamitin natin. So, later na. Dito ba tayo sa the principle of dimensional homogeneity. Kasi minsan hindi nyo napapasin kaso substitute nyo. By substituting lang ng substituting, the units, difference na. Okay? Different na siya ang unit mo. Okay? The principle is basic for the correctness of any equation. It states if an equation truly expresses a proper relationship between variables and physical phenomenon, then each of additive terms will have the same dimension or they should be dimensionally homogeneous. For example, if an equation of the following form expresses a relationship between variables in a process, then each of the additive terms should have the same dimension. In expression A plus B is equal to C over D, A, B, and C over D each should have the same dimension. This principle is used in dimensional analysis to form dimensionless group. Equations which are dimensionally homogeneous can be used without restriction about the units adopted, SI English. Another application of this principle is the checking of the equations derived. Note, some empirical equations used in fluid mechanics may appear to be non-homogeneous. In such cases, the numericals that are dimensional. So, check nyo, yung mga formula sa English units, formula sa SI, ang tawag doon is non-homogeneous. May mga equation yan na non-homogeneous. Yung constant niya pala, may units yun. So, the value of the constant is, in such equation, will vary with the system of units used. So, now, ito na. The Buckingham Pi Theorem. Okay? The statement of the theorem is as follows. If a relation among the n parameters exists in the form f of q1, q2 up to qn is equal to 0, then n parameters can be grouped into n minus m independent dimensionless ratio. Yan yung mga pi. Yung pi na yan magiging Reynolds number, Nusselt number. Yan. Or pi parameters expressed in the form d of pi 1, pi 2 up to pi n minus m is equal to 0. Yung n parameters, yan yung mga variables mo. Density, temperature. Later, may example naman tayo. So, pi 1 is equal to g1 of pi 2, pi 3 up to n minus m. Yan yung pi 1 mo. Okay? Nalipat lang sa pi 1 sa left side. Where m is the number of dimensions required to specify the dimension of all the parameters, Q1, Q2, Qn. Yan yung mga, in meters, anong dimension mo? In length, yung length, ang dimension mo is in meters. So, ang symbol niyan is L. Yung weight naman is mass is capital M. Later nga, later. So it is also possible to form new dimension pi parameters as a discrete function of n minus m parameters. For example, if there are four dimensionless parameter pi 1, pi 2, pi 3, and pi 4, it is all possible to obtain pi 6, 5, 5, 6, 5, 5, and 5, 6, etc. as pi 5 is equal to pi 1 over pi 3 over pi 4 kasi dimensionless nga siya, or pi 6 is equal to pi 1 is 0.5 or pi 2 is 0.23. Okay, the limitation of this exercise is that the exact functional relationship in one cannot be obtained from the analysis. Exact functional relationship, ayan, ano lang yan. So, parang as a function of. The functional relationship is generally arrived at through the use of experimental result. So, may mga constant ka na. Okay, wait tayo. Okay, determination of pi groups. Irrespective of the method used, the following step will systematize the procedure. So step 1, list all the parameters that influence the phenomenon concerned. From density, temperature, minsan, temperature, density, mass, viscosity, etc. This has to be very carefully done. If some parameters are left out, pi terms may be formed, but experiment will then be indicate this as inadequate to describe the phenomenon. If unsure, the parameters can be added. Later, experiment will show that pi terms with the doubtful parameters as useful or otherwise. Hence, a careful choice of parameters will help in solving the problem with less effort. Usually, 3 types of parameters may be identified in the fluid flow, namely fluid properties. geometry, and flow parameters like velocity and pressure. Step 2, select a set of primary dimension, the mass, length, and time. Force, length, and time. Depende sa parameters mo, ha? Mass, length, time, and temperature. Pag may temperature, so include mo, ito na gamitin mo. Are some of sets used popularly. Step 3, list the dimension of all parameters in terms of chosen set of primary dimensions. Okay, wait lang. Okay. Yan. Table 1, list the dimension of parameters involved. Yung variable mo, parameters, mass, yung variables, mass, length, time, force. Unit is, ang mass, kilogram, sa SI, SI. Length, M, time, S, force, N, temperature, degree C or Kelvin. Degree C means sa change of temperature niya. Okay? Itong temperature na to, change of temperature. Dimension sa MLT theta system, that is, ang ilalagay mo is M. Sa length, L. Sa time, T. Sa force is ML over T squared. Mass times acceleration. Acceleration is L over T squared. And temperature as theta. Sa FL theta system, so ang M is FT squared over L. Diba? Then, that is weight over acceleration due to gravity, ang unit. So, ang weight mo is F. So, ang acceleration due to gravity mo is L over T squared. So, ang lalabas niya. Sa length is L, times T, and force is F, and temperature is theta. Yan ang ilalagay mo. So, yung mga value niya, area is M squared, so magiging L squared sa both. Volume, M cube is L cube. Volume flow rate, M cubic meter per second is L cube over T. This is L cube over T rin niya. Okay? Mass flow rate, kilogram per second is M over T or FT over L. Hindi yan pita. Okay? Velocity is, check nyo lang ito, FT over L to. Okay? Velocity, mass meter per second is L over T both. Angular velocity, radius per second is 1 over T both. So force, so this is ML over T squared, so to F. Pressure stress bulk modulus, Newton per meter squared, is M over T LT squared, or F over L squared. Pressure Newton per meter squared. Moment is Newton meter, or ML squared over T squared, or FL. Work energy is joule Newton meter, pares lang. Power is the watts, joules per second. It is ML squared over T cube, FL over T. Okay. Okay. Density, so kilogram per cubic meter, M over L cube, FT squared over L exponent 4. Dynamic viscosity, kilogram meter second or Newton second per meter squared is M over LT. Doon sa kabila naman is FT over L squared. So kinematic viscosity, square meter per second. So magiging L squared over T, both. Surface tension, Newton per meter, magiging M over T squared, then F over L. Specific heat is joule per kilogram Kelvin. So L squared over T squared theta, both. Thermal conductivity is watts per meter Kelvin is ML squared, ML over T cube theta, or F over T theta. Okay. Convective heat, transfer coefficient watts per meter squared Kelvin is M over T cube theta or F over LT theta. LT theta, lahat yung denominator. Okay. So, expansion coefficient, meter per meter per Kelvin is 1 over T, both. Number 4, select from the list of parameters a set of repeating parameters equal to the number of primary dimensions. Some guidelines are necessary for the choice. 1, the chosen set should contain all the dimensions. 2, the two parameters with the same dimension should not be chosen. Say L, L squared, L cubed. Huwag mo nang Isa lang piliin mo dyan. So, the dependent parameters to be determined should not be chosen. Dependent, X and Y. So, Y ang dependent. Yung, ano mo, yung parang sa formula, siya ang Y. Step 5, set up a dimensional equation with the repeating set and one of the remaining parameters. In turn, to obtain n minus m such equation. So, determine pi terms numbering n to m. The equation, the form of the equation is pi 1 is equal to q over m plus 1 times q1a, q2a, q3c, then to qm. So as the left-hand side is dimensionless, an equation for each dimension in terms of a, b, c, d can be obtained. The solution of this set of equation will give the values of a, b, c, and d. Thus, the pi term will be defined. So yung pi 1, yung first one, ano mo. Step 6, check whether pi terms obtained are dimensionless. This step is essential because proceeding with the experiment to determine the functional relationship between the pi terms. Example 2. The pressure drop delta P per unit length inflow to a smooth circular pipe is found to depend on 1. The flow velocity U, 2. The diameter of the pipe D, 3. Density of the fluid rho, and 4. The dynamic viscosity mu. So A, using pi theorem, evaluate the dimensionless parameter for the flow. B, using Rayleigh method, power index, evaluate the dimensionless parameters. Okay, so given the pressure drop delta P per unit length, remember, flow velocity U, diameter of the pipe, the density of the fluid rho, and the dynamic viscosity is mu. Solution, ang sabi niya, dynamic viscosity is mu. Okay, solution, choosing the set mass, time, and length as primary dimension. The dimension of the parameters are tabulated. So, item 1, 2, 3, 4, 5, parameter pressure drop per meter, delta P is magiging Newton per meter squared. Pressure drop divided by meter. So, magiging where N is equal to kilogram, that's meter per second squared. So, magiging M over L squared T squared. Check niya. Yan. Madidirive mo yan. The diameter is D is meters or L dimension. Velocity U is meter per second. Ang unit used and dimension na is L over T. Length and time. Density is kilogram per cubic meter is M over L cube. Dynamic viscosity, mu is kilogram per meter squared is M over LT. Ayan. Ayusin nyo muna yan. Next. So using the Buckingham pi theorem. So there are 5 parameters and 3 dimensions. Ano yung 5 parameters? 1, 2, 3, 4, 5. Ang dimension mo is meter, length, and time. Okay? So as delta P is the dependent variable, yung sinasabi ko, delta P is a function of ito, velocity, diameter, etc. So let pi 1 is, so independent variables, ang repeating variables mo is D, rho, and U, velocity. So let pi 1 is equal to delta P, D, A, rho, B, U, C. Substituting dimensions, diba? Sa MLT, lahat yan 0. So delta P is M over L squared over T squared. So wala kang exponent yan. So L, ang diameter L exponent A, M, small letter B to small letter B. MB over L3B plus LC over TC. So using the principle of dimensional homogeneity and in turn comparing indices of mass, length, and time, paano yon? Ano ba nauna dito? So, unahin natin yung B. Ito. M, 1 plus B is equal to 0. So, therefore, B is negative 1. So, may B ka na. Next is L, tama. L is negative to ang exponent mo. Diba sa baba? Plus A minus 3B plus C is equal to 0. Substitute mo yung B ng negative 1, magiging A plus C is equal to negative 1. Next is T. To time. Negative 2 pa rin. Negative 2 and negative C equals to 0. So C is equal to negative 2. So negative 2, substitute mo dito, lalabas A is equal to 1. So substituting the values of the indices we obtained, so pi 1 is equal to delta P, D exponent 1, rho exponent negative 1, U exponent negative 2. So pi 1 is equal to delta P, D over rho U squared. So this represents the ratio of pressure force and the inertia force. Okay, check the dimension. So M over L squared T squared times L. So A mo naging so is 1. Then L cube over M. Okay. Bakit? Kasi negative yung ano, iba yung M, yung ano mo, B mo is negative 1. So akit na siya doon. Okay. So ito naman ganun din. So T squared over L squared. Nag-negative 1 din yung C mo. Negative. Okay. So it's equal to M exponent 0, L exponent 0, T exponent 0. Diba? So next, let pi 2 is equal to U, D, A, rho, B, U, C. Ilan yung pi mo? M minus N, yung number of pi. 3. 5 minus 3 is 2. So tama, dalawa lang. Okay. So substituting dimension and considering dalawa yata. Okay, check. MLT, M0, L0, T0 is equal to M over LT. That is yung mu times LA. Same siya, di ba? Rho, MB over 3B, LC over TC. Then, sa M, 1 plus B is 0. So, B again, negative 1. Then, sa L, negative 1 plus A minus 3B plus C is 0. So, A plus C is equal to negative 2. Then, negative 1 sa T, negative 1 minus C is equal to 0. So, C is negative 1. So, A is equal to negative 1. Si negative 1 mo to, substitute mo dito, so plus 1, negative 2 plus 1 is negative 1. So, meron ka ng, yun. Substituting the value of the indices, pi is equal to U, D is for negative 1, rho negative 1, U negative 1 is U over U, rho D. So, check. M over LT times T exponent L times L cube over M times 1 over L is M exponent 0, L exponent 0, T exponent 0. So this term may be recognized as the inverse of Reynolds number. So pi 2 can be defined as rho U D over mu. Also, pi 2 is equal to U D over D kinematic viscosity. Okay. So the new pi 2 is equal to 1 over D all pi 2. The significance of this pi term is that it is the ratio of inertia force to the viscous force. So then pi 1 is equal to the F of pi 2. So delta P D over rho U squared is F times U mu over U rho D. So that is the function. Ito na yung equation mo. It's a function of yan. So dalawa yun lang yung pi. M minus N. So in case D, U, and mu have been chosen as the repeating variables, pi 1 is equal to delta P D squared over U mu, and pi 2 is equal to rho U D over mu. The parameters pi 1 over pi 2 will give the dimensionless term. So delta P over rho U is squared. So another. In this case, pi 1 represents the ratio of force over viscous force. This law phenomenon is influenced by three forces, namely pressure force, viscous force, and inertia force. Next, the Rayleigh method, also called method of indices. So the following functional relationship is formed first. Then there can be two pi terms as there are pi variables in 3 dimensions. 5 minus 3 is 1. So ito na. Delta P exponent A, D exponent B, rho C mu D U E is equal to pi 1, pi 2. So substituting dimensions. So M exponent A, L2A, T exponent A, and LB, di ba yung mga units mo? MC over LTC times MD over LDTD times LE over A is equal to L0, M0, T0. So considering indices of MLT is equal as three equations are obtained as follows. A plus C plus D. Sa M, A, C, D is equal to 0. Sa B, negative 2A plus B minus 3C minus D plus E is equal to 0. And the last, negative 2A plus D minus E is equal to 0. There are 5 unknowns in 3 equations. So kulang ka ng isa. Hence, some assumptions are necessary based on the nature of the phenomenon. As delta P, the dependent variable, can be considered to appear only once, so we can assume A is 1. Similarly, studying the process mu appears only in the viscous force, so we can assume D as 1. So, dalawa, na-fulfill mo yung dalawa na pilapan nyo. Solving A is equal to 1, D is exponent 1, B is 0.0, C is equal to 2, A is negative 1. So pi 1 and pi 2 is delta P U over rho squared U cube. Multiply and divide by D, then pi 1 is equal to delta P D over rho U squared, and pi 2 is U mu over rho U D. Same as was obtained by pi theorem method. This method requires more expertise and understanding of the basics of phenomenon. Yan. Okay? So, aralan nyo mabuti yung pi method. Okay, another example. So, the example 3. The pressure drop delta P and flow of incompressible fluid to wrap pipe is found to depend on length L, average velocity U, fluid density rho, dynamic density mu, diameter D, and average roughness height E. Determine the dimensionless group to correlate the flow parameters. So given is the length L, average velocity U, fluid density rho, dynamic viscosity mu, diameter D, and average roughness height E, the pressure drop delta P. Required dimensionless group. So solution, the variables with units and dimension are listed. So ito yung variables 1, 2, 3, 4, 5, 6, 7. So a unit. So delta P, ang unit mas Newton per meter squared. Dimension is M over LT squared. Length L is L. U is meters per second or L over T. Rho is kilogram per cubic meter is M over L cube. Rho mu is kilogram meter per second or M over LT. D is equal to length is equal to. So tatlo ang L mo dyan. There are 7 parameters and 3 dimensions. So 4 pi terms can be identified. Selecting U, D, and rho as repeating variables, as these sets are separate conditions. No problem will arise in using A, B, C in all cases. So, ito yung repeating. So, consider, so let pi 1 as delta P, U, A, B, B, rho, C. Pi 2 is L, U, A, D, B, C, rho, Z is pi 3 is equal to mu, U, A, dB rho C, and pi 4 is EU A dV U C. Consider pi 1, M0, L0, T0 is equal to M over LT squared as L A over T A, L exponent B, M exponent C over L3C. Equating the indices of M, LT, so 1 plus 0 is 0, C is equal to negative 1, negative 1 plus A plus B minus 3C 0. So negative 2 minus A is equal to 0. So A is equal to negative 2. Then B is equal to 0. Substituting the values of indices, we have pi 1 as delta P U negative 2. D is exponent 0. Rho is negative 1. So pi 1 is delta P over rho U squared. Consider pi 2. Then M0, L0, T0 is equal to L exponent L A over TA times L exponent B times M exponent C over LTC. Equating indices of MLT, C is equal to 0. 1 plus A plus B minus 3C is equal to 0. Then A is equal to 0. So B is equal to negative 1. So mu 2 is equal to L exponent times U exponent 0, D exponent negative 1, rho exponent 0. Yung may mga exponent 0, wala na yon. So this one. So pi 2 is equal to L over D. Again, consider pi 3. M exponent 0, L exponent 0, T exponent is equal to M over LT, LA over TA, L over T, MC over TC. Comparing the indices of MLT gives 1 plus C is equal to 0 or C negative 1. Negative 1 plus A plus B minus T is equal to 0 or negative 1 minus C is equal to 0. So A is negative 1, therefore B negative 1. So pi 3 is equal to mu, U is point negative 1, D is point negative 1, rho is point negative 1. So pi 3 is equal to mu over rho du or rho du over mu. That is, reciprocal niya is pi Reynolds number. Consider pi 4. M0, L0, T0 is equal to L. And L exponent A, T exponent A, L exponent MC about L3C. This gives C is equal to 0. 1 plus A plus B minus 3C is equal to 0. So negative A is equal to 0. So A 0. B is negative 1. So pi 4 is equal to E is U is point 0. D is point negative 1. Rho is 0. So pi 4 is equal to A over D. These pi terms may be checked for dimensional nature. So the relationship can be expressed as pi 1 is equal to F times pi 2, pi 3, pi 4. So delta P over rho U squared is equal to F of L over D, A over D, rho U, D over mu. So this is now your answer. So mga important dimensionless parameters, kapag nabuo mo dyan, may mga tawag yon. Some of the important dimensionless group used in fluid mechanics are listed in table 2, indicating significance and area of application of each. Example, Reynolds number, RE, description, ang formula is rho U D over mu or U D over V. Kinematic mu, itong isa is, yung tawag dyan, basta V. Inertia force over viscous force. So application all types of fluid dynamics problem. Meron pang Prod number, FR, hindi sa inclined. KU over GL, 0.5 is U squared over GL. So inertia force over gravity force is, ang Prod number talaga is yung mu squared. So flow with free surface, open channel, and ship. Euler number, P over rho U squared, pressure of force over inertia force, for flow driven by pressure. Question number, CA is equal to rho U squared over EB. EB is the bulk modulus. Inertia force over compressibility force in compressible flow. So, nadoble lang. Okay, nadoble. So, Mach number M is U over C. C is velocity of sound. Inertia force over compressibility force. So, for compressible force. Strouhal number ST is equal to WL over U. W or omega is the frequency of oscillation. The local inertia force over convective inertia force. Unsteady flows with frequency of oscillation. Weber number, W is the rho U squared over L over sigma. Sigma is the surface tension. So inertia force over surface tension force. For problems influenced by surface tension, free surface flow. Lip, CL is L over 1/2 of rho U AU squared. L is the lip force, dynamic force for aerodynamics. Nag-get thesis, pero di alam yung lip force. Gumagawa ng mga turbine, ng mga blade. Pero di alam yung mga lip coefficient. Correlation of experimental data. Dimensional analysis can only lead to identification of relevant dimensionless group. The exact functional relations between them can be established only by experiment. The degree of difficulty involved in experimentation will depend on the number of pi terms. Yan. Okay? So, this is the end of dimensional analysis. So, diba yan sa internet. Okay? Thank you.